This is the intro video for Algebra 1, Section 5.6, and we are going to be looking at multiplying polynomials. So as you know from previous sections, there are different types of polynomials. There's monomials, binomials, trinomials, and then polynomials that have more than 3 terms. And so we're going to start in our video here today focusing on multiplying monomials together. And so we're going to do these first couple of examples together. And as we've seen with these, with exponents and polynomials, it's really important that we understand and correctly identify what is a base and what is an exponent and what that means for what we're going to be doing. So we're multiplying here, number 1, we're multiplying negative 9t to the 7th times negative 5t to the 4th. You can see we have a mix of constants and variables here, and I want to point out that negative 9 and negative 5 are both bases, right? They're both bases, they're not exponents. And so when you're just multiplying two bases together, numerical bases, then you just multiply them as we've always done. And so I would say I'm going to do that first. I'd go negative 9 times negative 5 is positive 45. That's going to be the first part of my product. I'll get rid of these highlights here, and now let's focus on the other two factors here. That would be the t to the 7th and the t to the 4th. And of course we want to correctly identify that that t is a base and the 7 is an exponent, and this t over here is also a base and the 4 is also an exponent. So if we are multiplying bases together like these, they're the same base, they're both t's. If we are multiplying those together, then to get the product we need to leave the base the same and add the exponents. So it's going to be 45, as we wrote before, t to the 7 plus 4, and of course 7 plus 4 is 11, so it'd be 45t to the 11th. Okay, so armed with that, maybe pause the video and try number 2. I'm going to go ahead and do the solution now, but feel free to try this on your own. All right, so like we did before, I want to try to identify any numerical bases I have. And I see the 6 and the negative 3 and what's understood to be a 1 out here. Those are all numerical bases. And so when you're multiplying numerical bases, you simply just multiply them as you've always done. So we're going to say 6 times negative 3 times 1 is negative 18. Okay, so once I've handled that, now I want to erase those highlights and take a look at the variables. Please notice that all the variables have a base of x. And the exponents on the first two are pretty clear, right? It's x squared and then x cubed. And then this last x, of course, does not appear to have an exponent, and so in those cases, that exponent is understood to be a 1. So let's remember from before, if you are multiplying like bases, then to get your product, you leave the base the same and you add your exponents. So I'm going to leave the base as an x, and I'm going to add my exponents, 2 plus 3 plus 1. And so we end up with negative 18 x to the 6th for our final product for number 2. Hope that went well for you. We're going to do a couple more examples. All right, in our first two examples, we looked at how to multiply a monomial times another monomial. In examples 3 and 4, we're going to be multiplying a monomial times a polynomial, so perhaps more than one term. So number 3 should look pretty familiar to you. Number 3 hopefully looks like the distributive property, and that's really what this is. If you're multiplying a monomial times a polynomial, it is the distributive property, but we want to be super careful with this. So I'm going to go ahead and write these little marks in that we usually associate with the distributive property. I'm going to write this next step out very carefully. So let me actually just focus on this first multiplication. I'm going to write this out as 27t to the 8th times 2t to the 5th. And then I'm going to do this other multiplication within the distributive property. So it's going to be plus, and I'm just copying this plus sign down right here, and plus 27t to the 8th times t to the 4th. So I hope at this point you can see how I've essentially just distributed this 27t to the 8th to each of the terms inside the parentheses. All right, so once I've done this, to simplify, I need to essentially do what I just did. I'm going to multiply each of the monomials within each term out. So I'm going to focus on my numerical bases first. 27 and 2 are numerical bases. 27 times 2 is just 54. Then I am going to focus on my variables. And so in this case, my variables are t to the 8 and t to the 5. Keep in mind those are variable bases. It's more important that they're the same base. If you're multiplying like bases together, then you get the product, you leave the base the same, and you add your exponents. So t to the 8 plus 5 completes that first term. We'll, of course, add those together here in a second. Plus. Now in the second term, I've got numerical base of 27, and then it doesn't seem like I have one right here. Technically, it's 1, and 27 times 1, of course, just 27. And then I've got my variable base of t to the 8, and the other one is t to the 4th. So like we've done before, if you're multiplying like bases, you leave the base the same, and then you add the exponents. So t to the 8 plus 4. So my final simplification here would be 54 t to the 13th plus 27 t to the 12 for my final evaluation there. Okay, so number 4 is pretty similar to what we just did. So again, feel free to pause the video and try if you want. I'm going to show you the solution now, though. All right, so please notice we've got a monomial, which is negative 9x squared, times this polynomial here. And of course, it's true that this polynomial is a little more complicated than what we had in number 3, but still it's just a polynomial. And so like we saw, number 3 is really just being the distributive property. We're going to use that same type of thinking here. So let me get rid of these labels here, and I'm going to use the distributive property to multiply this out. So here's my first part of my distributive property right here. So it's going to be negative 9x squared times 6x cubed. The next part of the distributive property would be plus negative 9x squared times x squared. The third part of the distributive property would be minus, that's this minus right here, and then negative 9x squared times x. So we can see here in the end that's going to be plus a positive. And then my last distributive property is here. So this is going to be plus negative 9x squared times 3. So we're going to follow that same process we've been doing here throughout. I'm going to identify my numerical bases first. So I've got negative 9 and 6 being multiplied there. Those are numerical bases, and so we just multiply those the way that you've done since you were in 4th grade. Negative 9 times 6 is negative 54. Then we take a look at the variables here, x squared and x cubed. Of course, those are the same base. Whenever you are multiplying like bases together, you leave the base the same, and you add the exponents. So that would be x to the, of course, 2 plus 3 is 5. I'll just skip that step on this one. Okay, now the next term. My numerical bases on this one are negative 9 and that understood 1. Of course, multiplying those together, we get minus 9. And then looking at my variables, I've got x squared and x squared. Whenever you're multiplying like bases, you leave the base the same, and you add the exponents. You get x to the 2 plus 2, so that would be x to the 4th. Okay, this next one, let's recognize we've got minus a negative, so that's really plus a positive. Similar to before, I have a numerical base of 9 and another numerical base that's just understood to be a 1. 9 times 1 is 9. And then my variables, I've got x squared times x. Whenever you're multiplying like bases, you leave the base the same, and you add the exponents, so 9x cubed. And then the last term, once again, I've got numerical bases of negative 9 and 3. So that would be minus 27. And there's nothing to multiply the x squared by, so it just remains x squared. This would be our final simplification for this multiplication, this product. All right, hope that went well for you. We'll practice these more when I see you in class next time. See you then.